Exponential decay. The amount of radium-226 remaining in the sample that originally contained 8 grams is approximately C of T equals A times 0.999567 raised to the T power, where T is times in years. Find to the nearest whole number the percentage of radium-226 left in the original pure sample after 1,000 years, 2,000 years, 3,000 years. Now, in the given formula, we do not have A. We don't know what A is, but A is the initial amount. Since the question is asking us for the percentage, we can assume that we start out with 100%. Or let's just say we start with 100 grams to see what happens. And so in this case, we are allowed to use 100 for A. But again, only because the question is asking us for the percentage. We want to know if we start out with 100, what amount we would end up after 1,000 years, 2,000 years, and so on. Now, if we were to use a graphing calculator such as Desmo.com, then we just simply type in C of T equals 100 times 0.999567 raised to the T power, precisely this. And all we need to do is type C of 1000, the next line, hit enter, type C 2000, where 2000 is the input in the parentheses, C 3000, and so on. And if we do this, we'll get C of 1000 equals 64.849996781, but there's no need to include that many decimal places. We just simply round it to 1 or 2 decimal places here, depending on what the question is asking us, the number of decimal places. In this case, if we round it to 2 decimal places, then it's 64.85. C of 2000 is 42.055, or rounded to 42.06. C of 3000 is 27.272772, and so on. So when we round it to 27.27. Now, we start with 100 and we end up with 64.85. And so this means to the nearest whole number, we simply round it to 65%. 42 is 42%. And 27.27 is 27%. And these are the answer for part A. Use a graph to estimate to the nearest 100 years when 1/2 of a sample of 100 grams will be left. In this case, if we were to use Desmo.com again, then on the graph, we simply type C of T equals 100, 0.999567 to the power of T. And on the second line, we grab another one. But this second equation is half of the initial amount. The initial amount is 100, and half of it would be 50. It doesn't matter whether we use X or T in the calculator. If we type C of X equals 100, 0.999567 at X as an input, then X has to be in the power instead of T. The second equation is Y equals 50. We see that the intersection of the two graphs will give us the solution. In this case, if we were to move the mouse or our cursor to the intersection, we will see that this intersection is when T is approximately 1600.455. When we round it to the nearest whole number, it is 1600, and this is after 1600 years.